Hello friends, welcome to my YouTube channel. Today we have an interesting topic. You must have seen many debates on this topic, but today you got everything together in this video and I'm sure it will be very helpful. This topic is on HVAC and this is what we generally see. What is better, chiller or VRF? Chiller versus VRF is the topic of today's video and we're going to look at in detail what is good, what is not that good, right? So chiller versus VRF, let us look at first how chiller works, how the chiller system works. So everybody must be knowing this, but just to refresh, we have a central chiller, which in this case is a water cooled chillers, for which a condenser pump is required to discharge or reject the heat in the cooling tower. The cold water comes back into the chiller and that's how the circuit works. The second circuit works on the chilled water pump, where we use from the chilled water coming from the chiller to the various units. These are HUs, there are FCUs, there are various units which actually take care of the air conditioning of their own area. So this HU must be taking care of this particular floor. We supply the chilled water to this HU and this HU will take the return air from this area. It will add some fresh air and the coil to which the chilled water is supplied, it will take the air over it and it becomes cool, get filtered because there's filters also, and it is supplied to the area which needs to be air conditioned. So this is the cycle of chilled water system. This is how chiller works, right? Just to give more analogy, it's in 3D, similar thing. We have chiller, we have condenser, pumps to the cooling tower. The chilled water pumps supplies the chilled water to the HUs. So this is how the system works in very simple manner. This is the air cooled chiller, which generally do not have cooling tower, so there is no pump which is required for condensed water, but we have chilled water pumps. They supply the chilled water to the unit, and as I said, the unit has a coil to which the chilled water is supplied. The blower picks up the air over the coil and supplies to the area where it is to be conditioned. This is how the return air is picked up, comes back to the unit again, goes over the coil, and this is how the cycle works. So this is how the chiller system works, right? This is how the VRF works. VRF, we have one outdoor unit. It can be connected to multiple indoor units. Again, there is always a limit, but this is the advantage of this, that it can work with different type of indoor units and different places. So they are connected by a copper piping. In chilled water system or chiller system, there is a chilled water. In this case, the gas, the refrigerant only, it travels to the different units through the copper pipe. This is how it works. This is the outdoor unit just I spoke about. These are the outdoor units, top of the building, and you can see these are the machines. These are the machines, different type of machines at different floors. They are connected through a refrigerant piping, which is generally used as a copper. Hope this system clarity is there. Now we are going to look at the comparison, the chiller versus VRF, in 4 segments. One is technology, second is installation, maintenance, and then the important aspect of money, the life cycle cost. So let us look at the first technology comparison, and we are going to look at merits and demerits. The merit of VRF is that we have different, as I said, indoor units which can be linked. It can be a high wall, it can be cassette, it can be concealed unit, it can be ducted unit. This can be connected to one ODU. So we have options available. Based on your interior, you can take your own decision. With the current available options in VRF, one can get a lead rating of gold. Again, one of the merit. The VRF operation is very simple. It is as good as running a normal split AC, which is there, in my own house. So we don't need a skilled manpower to operate this, right? So good option for providing air conditioning to apartments, villas, and small installations. So these are the merits. Let us look at the demerits of VRF. It's a complex system. It has got complex architecture, large amount of refrigerant piping, which has a refrigerant in it. So that's the demerit. If it is decided to use for large capacity, more space will be required to have more number of outdoor units. So you will require a space. This is not beneficial, and that's my whole humble advice to everyone. Don't go and sell VRF everyone. This is not advisable where there's a limited diversity. So if it's office which works 24/7, the diversity is very, very less. This works very well when it has an issue of when it has a large diversity. So that's another important demerit. Can be hazardous if the refrigerant piping leaks. Most of the refrigerant pipings are going above the ceiling within the air conditioned area. Then it can have issues. It also has an issues of limited air quantity to be delivered per unit. So 350 CFM per ton is the limit, and limitation from indoor air quality. As if you look at high volume units, if you look at cassette units, it has a limited amount of fresh air which can be pumped into. So indoor air quality is one of the demerit of VRF. It can be worked out, but this is what as a system we have demerit. Let us look at water cooled chiller merits. It is a proven technology for over many decades, right? It's a highly energy efficient, and anybody, and you can achieve lead rating up to platinum, right? With proper system designing, we can always get higher diversity. We can get the chiller operating at very good efficiency in part load condition. Project size is not a constraint. There is no hazardous component in the air conditioning area because the water gets circulated, which is a non-hazardous. These are some of the merits. The demerits is availability of water, and today the water has become scarce. So how to make the water available is one of the demerit, right? And it requires a plant room, so that requires a space. It will have H rooms, that will require space. It will need cooling tower, that will need a space. So that's a space required is one of the demerit. And for chill water system, you need a trained manpower to operate it because it's a complex system. We need a skilled manpower, trained manpower to operate it. Let us look at now the comparison with respect to installation, right? So when you talk about chillers are installed and connected to various units, the indoor units like HUs, FCUs, through steel pipes. The steel pipes are of larger diameter and they will need a lot of space, right? And generally they are done through welding. On the other hand, VRF, as I said, connected through a small copper pipes, which has got refrigerant in it, and this will need a lesser height, and that's how you can get a more height in the ceiling, right? That's the comparison. The installation of chiller is completely harder because for the large capacity, each chiller weight is different. You may need proper hoisting of the chillers to lift it and keep it where it is. In terms of installation skills, chiller requires skilled workers. We need specialists to install the chillers. For VRF, a relatively less experience or people who done the split AC installation can do that, right, with little bit of training. For building owners, one have to pay large amount of sum in the beginning for chillers. So chillers come in large capacity, so you have to pay upfront. In case of VRF, you can go in modular way. So if you are building of 10-story building and if you know all the floors will not be occupied, you might go floor wise ordering of VRF. But for the chiller, you have to order once, and the cost of the outflow will be more in case of chiller, but you can go in modular way with respect to VRF. Project schedule wise, VRF are more progressive because you can get your units whenever you need. Chiller has got little high delivery period, right? The lead time is high. So if one foresee the difficulty in time and fund management, they can consider VRF because they can pay a little less. They can go in modular way and do not invest all the money in the full capacity of chiller, which is not required in the start of the project operation. Right. So this is one important aspect. Let us look at maintenance aspect. Chillers are easier to maintain and service than VRF because with the VRF there are multiple indoor units, there are multiple copper pipes that needs more attention. Chillers, if you have good operating team operating the chiller, that can be easy. This is a technical comparison. So if you look at overall complexity, chiller is a little simpler, but VRF is a little complicated. Occupied space need large room in chillers and can be scattered for VRF. Design flexibility limited by chiller capacity. VRF is flexible because you can go in modular way. Efficiency, combined efficiency, 0.83 kilowatt per ton. Here it is 0.95. This is the total I am talking about. Performance and reliability. Chillers are proven, heavily dependent on installation capacity. VRF very important because workmanship plays very important role. Repairability require a specialist in case of chiller. VRF it is little easy to do. So the last point is on life cycle cost comparison. So this is one example which is in front of you, and this has got some assumptions to do it. So what is life cycle cost? Is the initial capex plus the operation and maintenance cost. So if you look at a study of 1000 ton capacity system in VRF, that will cost you 50 to 65,000 per ton. Screw will cost you 50 to 55,000. So this is the total cost of capex for 1000 ton capacity. Let us look at the operation cost. In operation cost, obviously we have IKW per ton, and that is for with respect to the IPLV. This is a 0.9, where in case of screw chiller is 0.5. Condenser water pumps not applicable, but they are applicable in chillers. Similarly, chilled water pumps, AHUs, cooling tower not applicable in VRF. They are applicable, they will have their own IKW per ton. So overall, if you look at VRF, it is 0.9. However, in screw chiller, we can get up to 0.73. So with respect to the cost of kilowatt hours, which is considered 8.75, you can consider whatever. So total operation cost for VRF is 3 crore 54 lakhs, 37,500. In case of chiller, it is 2.87 crores. So chillers are better. Cost of water makeup, which in case of VRF not required, but if you calculate here, it is around 5.5 lakhs. Right now, let us look at the CMC cost. 1800 to 2000 rupees per ton is the VRF maintenance cost. It is lesser, 1200 to 1500 in chillers. So operation cost is not required in VRF because anybody can operate it, but chiller you can have your own operation team. The total maintenance cost with respect to CMC and operation is this, and if you add all these 2A, 3 and 5A, this is the total operation cost, 3.72 crores and 3.8 crores. So if you add for 15 years, this is what the cost, this is the cost for chillers. Hence the life cycle cost, as I said, initial operation and maintenance cost is, for considering 15 years, O&M cost is 61.6 crores if you go to VRF, but 51.4 crores if you go to. So the screw chiller always have a merit over VRF when it comes to life cycle cost comparison. So in conclusion, for a smaller system, maybe 100, 200, 300, 400 TRs, we can use VRF systems. For large systems, it has to be chillers because chillers can work better. It can take care of your operation cost, and VRF will have more complicated structure, difficult to maintain, and obviously the operation cost will be higher. So this is in nutshell the comparison. Please go through my course which is available on my own app powered by Class Plus. That course name is Good Installation and Practice in HVAC, VRF, chillers, everything is covered in that course. The links are there in the description box. Please click the link and take the full benefit of this course. Thank you very much. Please subscribe my channel. Follow me on YouTube, Facebook, LinkedIn and ajazkazi.com.